How are you? I hope you are healthy and good. I am also fine. Today I am going to discuss about a very natural topic, that is Compton effect. Compton effect is because of the scattering. Compton scattering is inelastic scattering. So first we'll understand what is inelastic scattering. Inelastic scattering is a fundamental scattering process in which the kinetic energy of an incident particle is not conserved. So, inelastic scattering, this kinetic energy, is not conserved. Inelastic collision in dynamics refers to a process in which the total macroscopic kinetic energy is not conserved. While in general, scattering due to inelastic collision will be inelastic. But since elastic collisions often transfer kinetic energy between particles of interaction, scattering due to elastic collisions can also be inelastic, and that is in the case of Compton scattering. So, in scattering is inelastic. But collision is elastic, in which there is a transfer of energy. When an electron is the incident particle, the probability of inelastic scattering, depending on the energy of the electron, is usually smaller than that of the elastic scattering. But when photon is the incident particle and it interacts with a matter, that is gas, liquid, and solid, scattering process is called Raman scattering. And this Raman scattering is inelastic scattering. In inelastic scattering, when a high energy photon collides with a free electron, actually here free electrons means weakly bound electron, because free electron in reality doesn't participate in interaction. So here free electrons means a weakly bound electron. So when a high energy photon collides with such electron, transfer energy to the electron. The process is called Compton scattering. But when an electron with relativistic energy collides with an infrared or visible photon, in this case, electrons give away its energy to the photon, and that is the case of inverse scattering, inverse Compton scattering. As we know that in Compton scattering, X-ray photons with the help of X-ray tube falls graphite target. So if this is X-ray coming from the X-ray tube, and it falls on the graphite. After scattering, it is passing through the slit. So here, after scattering from the electron in the graphite, this X-ray photon is diffracted and with the help of single crystal or single crystal, it is being recorded in the ionization chamber. So since scattering is inelastic, so the photon energy is transferred to the electron, and the energy after scattering decreases, and hence the wavelength of the photon increases. This shift in wavelength of the photon after scattering with the electron is known as Compton shift. We will derive this Compton shift. Compton in 1927 received Nobel Prize in Physics for this discovery. Here, the energy of a scattered photon is measured using Bragg's scattering in the crystal in conjunction with the ionization chamber. In this chamber, the total energy deposited over time is measured, not the energy of the single scattered photons. Now, what happens when scattered with the free electron, it loses some energy and takes a different direction after scattering from the electron. Let's the angle of scattering is theta, and lambda is the incident wavelength, and after scattering the wavelength becomes lambda prime, and when photon interacts with the electron, it gets recoiled in the direction. Let's say it is I with the direction of the incoming path of photon. We will derive that shift in wavelength known as Compton shift may be given by h by m is c into 1 minus cos theta. So we can see that the shift depends on the angle of scattering, not at the wavelength. Here h is Planck constant, M is the rest mass of electron and C is the speed of light. Theta is the scattering angle. R theta is equal to 0. This Compton shift delta lambda is equal to lambda prime and lambda is equal to 0. But for theta is equal to 90 degree, delta lambda Compton shift becomes h by 1 minus cos 90, that is h by n ac. Implies that delta lambda, after substituting the value of h, m, e and c, it comes out 2.43 into 10 to the power minus 12 meter. And for theta is equal to 180 degree, this Compton shift becomes twice of the h by mec. Thus, Compton found that some X-rays experienced no wavelength shift despite being scattered through large angles. In each of these cases, the photon failed to eject an electron. Thus, the magnitude of the shift is related not to the Compton wavelength of the electron but to the Compton wavelength of the entire atom. Now we will derive this formula with the help of conservation of energy, and conservation of momentum. Of the system. So, conservation of energy of photon plus energy of rest electron is equal to energy of scattered photon plus energy of recoiled electron. So this is equation 1. Since we know that with the help of Einstein's energy mass equivalence formula, E is equal to mc square, which Compton uses, and E is equal to h nu energy quantum This gives mc square is equal to h nu is equal to h c by lambda, implies that mc is equal to h nu by c. This is nothing but the momentum of the photon. So we will use E is equal to h nu concept. Then this gives now conservation of momentum gives momentum of photon plus momentum of electron is equal to momentum of scattered photon plus momentum of recoil electron. Here PE can be ignored as we are assuming electron in the rest position. Electron in rest position. So photon energy before scattering is equal to h nu, after scattering is equal to h nu prime, where h is the Planck constant, and since electron is in rest position, almost rest position, the total energy is only the mass energy equivalence of its rest mass me, that is E is equal to me c square from the Einstein's mass energy equivalence formula. And after scattering, the electron might be accelerated to a significant fraction of the speed of light that requires its total energy to be represented using the relativistic energy momentum relation. Given as E is equal to C whole square plus MEC square whole square. Substituting these values, we get h nu plus MEC square is equal to h nu prime plus square root PE times C whole square plus MEC square whole square. This is equation number 2. Now PE prime square C square is equal to h nu minus h nu prime plus m e c square whole square minus m e square c to the power 4. This is equation number 3. Since the magnitude of the momentum gained by the electron exceeds the energy divided by c lost by the photon, that is 1 by c h nu minus h nu prime plus mec square whole square minus me square c to the power 4 is greater than h nu prime divided by c. Now equation 3 gives that the electron's momentum change involves a relativistic change in the energy of the electron. It is not simply related to change in energy occurring in classical physics. It is relativistic change in energy. So the change of the magnitude of the momentum of the photon is not just related to change of its energy. It also involves a change in direction. So the momentum conservation gives that P prime is equal to P gamma minus P gamma prime. These are the vector quantity. Now P E dot P E prime dot, that is, if we take the scalar product of this equation 4, it gives Pe prime square, that is equal to P gamma minus P gamma prime into scalar product P gamma minus P gamma prime, which is equal to P gamma square plus P gamma prime square minus 2 P gamma prime cos theta. So we have P E square, P prime square is equal to P gamma square plus P gamma prime square minus 2 P gamma prime cos theta. Further, to solve it, let us multiply both sides by c square. So it gives P prime square c square is equal to P gamma square c square plus P gamma prime square c square minus 2c square P gamma prime cos theta. So PE prime square C square is equal to this PC gives H nu whole square plus H nu prime whole square minus 2 P gamma C into P gamma prime C cos theta is further H nu prime square plus H nu square minus 2 H nu prime cos theta. This is equation number 5. Now substituting this value of PEC from equation 2, we get that H nu minus H nu prime plus MEC square whole square minus ME square C to the power 4 is equal to H nu whole square plus H nu prime whole square minus 2H square nu prime cos theta. So this comes from the equation 2 and 5. This further reduces to H square nu square plus H square nu prime square plus ME square C to the power 4 minus 2 H square nu prime minus 2 H nu prime ME C square plus 2 H nu ME C square minus ME square C to the power 4 is equal to H square nu square plus H square nu prime square minus 2 H square nu prime cos theta. After cancellation, reduces to 2 H nu ME C square minus 2 H nu prime ME C square is equal to 2 H square nu prime one minus cos theta. Further, dividing both sides by 2h nu prime MEC, we get C by nu prime minus C by nu is equal to h by MEC 1 minus cos theta. It's nothing but lambda prime minus lambda is equal to h by MC 1 minus cos theta. Also, angle I of the recoil electron with the direction of incoming photon path is given by cot I is equal to 1 plus h nu divided by h nu MC square and theta by 2. Thus, we can see that angle of recoil depends on the scattering angle of the photon. So friends, this is all about the Compton scattering and Compton effect. Hope you understand and like this video lecture. If there is any query regarding this lecture, please tell us by comment and support us and subscribe the video, and don't forget to press the bell icon so that to get the latest update videos. Thank you friends. Bye. Take care.